when we are looking at motivation here, it's in the context of a larger perspective on what we call the vectors of intelligence. The idea is that the systems of the future will be not evaluated in a single dimension of performance, but rather they will have many capabilities across fields. We will no longer build systems that are task-specific. We're currently building systems that are more broad and flexible. And this is in this area of deep learning, we increasingly have models that are able to perform many, many tasks, some of them which they were not even built for. But the question is, how can we get to systems that go beyond this flexibility towards generality? And this means that we are optimizing many dimensions. For instance, we need to get our representations away from operator-specific representations towards universal representations, so we can represent everything that happens in the world in suitable structures for it. Or we want to go from offline learning, as we currently have in neural networks, towards online learning, and eventually to self-improving systems that have an idea what they learn and why. We want to have systems that go from the open loop control that you currently have mostly when you act on the world to closed loop systems that have feedback to the environment and eventually construct new feedback loops towards self-extending. And with respect to autonomous systems, we want to go from task-directed systems towards goal-directedness and then eventually self-directedness. So basically systems figure out what they want to achieve and why and what the context is. And when you have collaborative systems, you need to go from systems that show what their inner state is to the user towards explainability, so they can tell the user what their state is, or explain it in terms that the user can understand. And that also means that they have to increasingly track the state that the user is in. So they have to understand what the user can understand in a given context. And eventually, these systems have to be able to understand what the intentions are, so they can truly collaborate and adopt the goals of the ones that they're interacting with. So when we are talking about autonomous systems, we go from task-directed to goal-directed and then to self-directed systems. For collaborative systems, you go from transparency to explainability and then goal adoption. And there's, of course, the question, does an AI system need motivation at all? It's conceivable that you are only dealing with oracles, right? An oracle is a system that is responding in a similar way as Google search to a question that you pose to it. And after that particular task is over, the system is done with its task and goes back into quiescence. And it's different from a system that is continuously interacting with the environment and serves its own goals in this purpose. But there is not necessarily a very strict gap between such systems, because, for instance, when you look at GPT-3, that is a system that is not goal interested by itself. It has no motivation. It's just a system that is basically doing autocomplete and is creating some story or response based on the autocompletion. But GPT-3 is very well capable of creating a story about a motivated agent. And so if you put an underlying motivation or combine it with a motivational system, then even such a system is able to switch from the oracle state to something that is more agentic. What is an agent? I think that the notion of agent can be best understood when you come from cybernetics. So when you take the concept of a feedback loop, where you have a controller and a regulated system, the controller is affecting the regulated system with actuators or effectors, and it gets information about the regulated system via sensors, and the sensors tell the controller in which way the regulated system deviates from the ideal state, from the set point of that system. And there's an environment which disturbs the regulated system. And the easiest example of such a control system is the thermostat. But the thermostat is not an agent, because the thermostat is only modeling the deviation of the next frame. So it actually doesn't have a model of reality. It's just reacting. And you want to have a system that is able to integrate the expected deviation over a longer time frame and optimize over a longer time frame. And as soon as you have a controller that is able to model the future, then you will have a branching expectation horizon, and the control becomes decision making. And this is when you have an agent. So an agent basically is a controller that is able to model the future and is combined with a set point generator. So we basically have stages in which we can understand intelligent agency. The simplest system that is acting on the environment is the regulator with a feedback loop. And when you are at a modeling system, you have a predictive controller. And when you combine this with a set point generator, you have an agent. And a sentient system is one that is so general in its modeling capabilities that it can discover itself and to discover and model the relationship that it has to its environment, so it understands what it is doing and why it's doing that. And you can also go a step further and think about agents that are capable of transcending themselves, which means they link up with other agents in combined collaborative agency that is coherent and is basically instantiating agents on the next level. And humans are of that type. For instance, when we have close relationships with others, we are going to link up into a shared agent. And we also state building, that is, our civilization itself can become a coherent agent that is able to act on its environment due to the way in which people are collaborating. And in our own mind, we have a variety of agents that interact. And I think we can see the way in which we deal with reality as a perception agent, that is a system that is trying to track reality as it progresses and generates functions that predict the sensory patterns. And we have an attention system that is interacting with this perception system and is creating actively a coherent model of the world. And you have a motivation agent that is giving a motive force to the perception agent and the attention agent. And what we are looking today is mostly the actions on the structure of this motivation agent. The core of the motivation is valence. Valence is what determines the value of the operations that we can perform on the environment. It's grounded in a multi-dimensional motivation system. And at the root of valence are needs that we have. And there's a big question, what is the minimal set of needs that you would need to become an interesting agent that acts on its environment? And the most radical proposal comes from Carl Friston with the free energy principle. And what he says is basically you only need to minimize the prediction error. And this will lead you to structure discovery. And if you are trying to minimize the prediction error in a system that has set point deviations, you get all the other behaviors. And I would say that this prediction error is equivalent to an aesthetic need. It's a need to discover structure in the world at large, but I don't think that it's sufficient to understand human behavior. GPT-3 is an example of a system that is minimizing prediction error, nothing else. And it seems that the order in which GPT-3 learns things is very different from the order in people learn things. Basically, meaning is if GPT-3 is able to capture at all the long tail of style. And so GPT-3 is only looking for an aesthetic structure in a way, and not even for symmetries in it. It's also in this regard incomplete because it's not necessarily coherent. It's not directly optimizing for coherence. So I suspect that while if you zoom out long enough, there might be a convergence between systems that only minimize prediction error and properly motivated systems in order to get a system that within its lifetime, in a finite lifetime, is going to get to an interesting behavior on the world. You need to put in additional needs. And also for the purpose of learnability, you might even have to have something like transitional needs, motivational reflexes. For instance, when a baby is born, the baby does not have an understanding of hunger and thirst. These are two complicated desires, and they cannot yet be matched on actions that are available to affordances that are available to the infant. So instead, the infant has hardwired reflexes. When the baby is born, it gets hungry, it has a seeking reflex. So it will turn its head around and open and close its mouth. And it has a sucking reflex. If you put something into its mouth, it will reflexively suck. And it has a swallowing reflex. If you put liquid into its mouth, it will swallow that liquid. So if you have a newborn infant and you want to give it medicine, you just squirt it into its mouth and it swallow it regardless of whether it's tasty or not. But as a result of these three reflexes, the baby gets into a situation where it learns to connect hunger with swallowing and the satisfaction that comes afterwards. And once that learning is online, the reflexes are turned off because they would interfere with the properly learned behavior. And at this point, you can no longer give them medicine in this convenient way. And it's interesting to think about how many of these transitional reflexes we have. I suspect that many of our moral emotions are actually reflexes that are built into us before we understand the true symmetries, the economy and the game theory of the social reality. And the older we get, the more these moral reflexes are replaced by true understanding. And the moral reflexes are just no longer active because they're replaced by an understanding of what are the status of the world that we want to achieve, what are the behaviors that get us there. The individual needs can be understood as physiological needs, social needs, and cognitive needs. And physiological needs, you have hundreds of them, but they're sustenance, pain avoidance, rest, libido, and so on. Then we have a bunch of social needs, for instance, a need to affiliate with others, a need to care, a need for affection, and a need for legitimacy, which means that we try to serve internalized normative goals, a need for dominance to rise up in hierarchies and so on. And obviously not everybody has the same needs and the same strengths. There are individual differences between those needs. And we have cognitive needs, a need for competence of being basically more skillful, a need for reducing uncertainty environment, which lets us explore, and our need for aesthetics, which lets us discover structure. And each need can be understood as a target value and a current value, and the deviation.
Joscha, your video froze.
Okay, thanks for letting me know. So we can, the urge indicator changes over time, and the stronger it changes over a unit of time, the stronger of a pleasure signal you get. If it goes in the wrong direction, you get a displeasure signal, and those pleasure.
I think you're having connection issues again.
Oh, okay. So both pleasure signals and displeasure signals are reinforcement signals. And when we act, we do not act directly on these reinforcements. When pleasure and displeasure happen, it's too late. We need to act on models of them. So basically on future pleasure and displeasure, on anticipated pleasure and displeasure. And the urge signals are part of a larger architecture. They give rise to priming and modulation, and to learning and decision-making in our cognitive systems. And the modulation gives rise to emotional states. So we get modulated based on our changes in our urges and the expected changes into different configurations that adapt us to the environment. And that when we perceive them ourselves, we perceive them as emotional states that we are in. And the same is true when we perceive them in others. And this gives rise to what I call the engine of motivation. So here you see a bunch of tanks. To the upper left, you see the physiological needs. At the bottom, you see the social needs. And to the top right, you see the cognitive needs. Each of these tanks can run dry. And when they do this, they create pain signals. And when the level increases, they create pleasure signals. And they interact to produce an integrated sense of valence and urgency and urge strength. And they affect a number of modulators that configure the cognitive system at any given moment. And we can use our models of needs to map them on the big five and in this way explain personality. Basically, the hypothesis here is that personality can be understood as parameterization of the motivational system. But are needs not a hierarchy? Don't we all know Maslow's hierarchy of needs? I am not a big believer in this hierarchy of needs because, first of all, I don't think that these are needs. These are purposes, right? The needs are more basic things than self-actualization and self-esteem, which are conceptually quite difficult to understand. Or safety, this is something that you cannot measure directly. You have to construct these structures that you see here. So this is actually a hierarchy of not of needs, but of purposes, of models of needs. And what we see is that basically on the lower level, you have organismic purposes, and the next level, you have relationship purposes. And at the top in Maslow's hierarchy, you have purposes that can be integrated over the lifespan of the organism, which is basically the ego. And in our own organism or our own mind, they are not organized into a strict hierarchy. our needs are in direct competition. They're next to each other. They might have different strengths and might be replenished in different frequency, but they are directly competing. You're not just waiting when you want to stage a revolution until you have eaten. Sometimes you will not eat for a couple of days because you have more important social or high-level goals. And of course, we have goals that are above the ego, basically what we could call sacredness, purposes that are so important that we are willing to sacrifice the goals of the organism or of the ego for it. And once we have sacredness, all our other purposes become instrumental to satisfying our sacredness, our higher meaning. There's nothing esoteric about this. It's just the way in which most human beings are implemented. And this sense of having purposes above the level of the organism is what allows us to link up into higher level agents. And I think that our ethics depends on having this notion of sacredness. It depends on having shared purposes above the ego. Basically, ethics is best understood, I think, as the negotiation of conflicts of interest under conditions of shared purpose. If you do not share purposes with anybody else, there's no reason why you should have ethics, right? You are a singleton that is interacting with other singletons. You're maximizing your own goals, and there's only game theory that you have to obey. All your interactions are going to be transactional. And if you want to have non-transactional interaction, it means that you have to act on a shared purpose. It means that you are giving something to somebody else, not because you expect to get something in return from this particular agent, but because you and this other agent are part of something larger. And you want that other agent to achieve their goals because they're ultimately also your goals as part of that something larger. So you don't need this direct return from this other agent in this context. And these shared purposes need to be given by innate needs. You cannot infer them something. There are sociopaths which are completely functional as cognitive agents. They don't have any cognitive deficit, but all their interactions are going to be transactional. And the interesting thing about our own species is that we can link up in this shared purpose, that we are able to build societies at scale, that we can build coherent agents at scale. And when we think about AGI or artificial intelligence systems that are ethically interacting with people, it means that we have to build them in such a way that they are going to share purposes with us. And these shared purposes need to play out in a coherent world, which means before we can have ethics, we need to develop a shared aesthetics of what the world should be do not converge to a coherent reality that is sustainable. Okay, so it makes no sense if we have shared impulses that do not converge to a coherent reality that is workable and sustainable. This is it for me.
Thank you, Joscha.